Hello, in this second video what I'll be looking at is some of the different types of air pollution. The first one we're going to look at, and if you open your notes, is photochemical brown air smog. And this is basically a smog created by the reaction of certain chemicals with sunlight. And as it says in the notes, any chemical reaction activated by light is called a photochemical reaction. Pollution known as photochemical smog is a mixture of primary, as we said in the previous video, unreacted, and secondary pollutants formed under the influence of sunlight. And the resultant mixture of more than 100 different chemicals is dominated by ozone, which is a highly reactive gas that is harmful to most living organisms. We've talked about ozone before. In terms of like the ozone shield, this is stratospheric ozone. What we don't want is what's termed tropospheric ozone. It's the air we breathe. We do not want ozone in an area where we're breathing. And you may have felt the effects of ozone in respect of, for example, on a very hot day, maybe in Philadelphia, you may have had burning eyes, or you might have had a difficulty in breathing on very, very hot days. This is often when you've got very high ozone levels. So the hotter the day, the higher the levels of ozone and other components of photochemical smog. It comes from basically traffic. As traffic increases in the morning during rush hour, levels of nitric oxide, nitrogen dioxide and nitrous oxide and unburnt hydrocarbons rise and begin to react in the presence of sunlight, and what they produce is this photochemical smog. On sunny days, the photochemical smog builds up to a peak level by early afternoon, and this will often irritate people's eyes or make it difficult to breathe. You may have felt this, like I said. And according to the American Lung Association, Philadelphia was over healthy limits of photochemical smog 136 days last year. And virtually all modern cities have photochemical smog, but it's more common in ones which are warm and dry and that have a large amount of motor vehicles. For example, what we could say is in Los Angeles, you get a large amount of photochemical smog, but in other places, for example, like Rome also. Okay, in some places you don't get so much. For example, if I was talking about London, because it rains, it's wetter, the climate, you don't tend to get as much photochemical smog. So, and there's a diagram just explaining some of those reactions, some of those gases to form this photochemical smog. Okay, but it's also called, like I said, it's also called brown air smog. The reason being the nitrogen dioxide gives it a reddish colour. And the second type of smog is called industrial grey air smog. And this comes from like the burning of coal. And like 50 years ago in cities, for example, like London, Chicago, Pittsburgh, we used to use a lot of coal and heavy oils, and this contained large amounts of sulfur impurities. And when we burnt the coal, it released a lot of sulfur dioxide. That sulfur dioxide went up into the air and it was in the clouds. And in the winter, those clouds often come down to ground level as fog. And what we saw was that fog would basically contain a lot of pollutants which would influence and hinder people. It would harm people. So industrial grey air smog is basically a variety of things like droplets of sulfuric acid. It's also sulfur dioxide and various suspended and solid particulates, lots of dusts and aerosols within it. And industrial smog, however, is rarely a problem in most developed countries because one of the reasons, if you think about the fuels we use in our cities, we've moved away from the burning of a lot of coal in our cities, heavy oil in our cities. We use more electricity. We have different transportation in our cities. Also, we have more pollution controls. However, a lot of our industry has also moved out since the 1970s. We've had a lot more deindustrialization, with basically a lot of our manufactured goods being produced overseas. So we see urban areas of places like China and India and some of the Eastern European countries like the Ukraine suffer from industrial grey air smog at this moment. Next thing we want to look at is some of the factors that influence the formation of smog. Just in case you're unaware of what smog is is just like the abbreviation of like smoke and fog. So some of the factors that influence the creation of smogs is things like the local climate, how warm, how windy it is, or the topography. Is it in a mountain? Is it in a valley? The population density, as we burn a lot more things like fossil fuels or use automobiles. The amount of industry in an area, the types of industry, the fuels used in industry, what type of heating we have in an area. So all these factors can influence the formation of smog. And if we go down a little bit further, what we can say, in areas with high annual precipitation, large amount of rain and snow, it helps clean the air. It brings a lot of pollutants down to ground level, like you may have felt after it's rained. The air feels a lot cleaner because a lot of the dust have been brought down to ground level. Winds also help sweep pollution away and bring in fresh air, but they may also transfer some of the pollutants downwind, away from the city, so it may pollute a much wider sort of like area. Hills and mountains tend to also reduce the flow of air in valleys, and also it may allow, with this lower airflow, to for pollutants to build up at ground level. Also, if we look in cities, we have buildings, tall buildings, which may slow the wind speed and again reduce the dilution of pollutants. So normally during the day the sun warms the air. This is what normally happens. Normally during the day the sun warms the air near the Earth's surface, and this heated air then expands and rises, carrying low-level pollutants higher into the troposphere, or the lower atmosphere. Above it, the colder, denser air from surrounding high-pressure areas then sinks, so it comes down into close to the ground level. This continual mixing helps the air from helps remove the pollutants from the air and stops it from becoming dangerous concentrations near the ground. However, occasionally a lower layer of denser, cooler air can be trapped beneath a layer of less dense warm air in urban basins or valleys, causing a phenomena called a thermal inversion or a temperature inversion. And the change in temperature in the warm air pollutants above the pool of cool air prevents sending air currents that would disperse and dilute pollutants from developing. So basically you've got almost like a cap over the pollutants. They're not rising up because you have warm air above it. And these inversions usually last a few hours. However, when high pressure air masses stall over areas, they can last for several days. This allows air pollutants at ground level to build up to harmful, even lethal levels. And some examples of this include London. If you look back at the, other sort of like section in the module that I put in, for example, what we saw. If we look at for example, some of the episodes, within this episode's area, what we've got is we're going to talk about Donora in a minute, but also, like I said, we've got the London smog. So this is an area that had thermal inversion. So as I said, like London had the Great Smog in the 1950s, where thousands of people were killed and thousands and thousands of people became sick from the air pollution. In the United States, the first major air pollution disaster, again on the previous handout, occurred in Donora, Pennsylvania, which is a small industrial town southeast of Pittsburgh. The town is surrounded by mountains, so we're talking about the topography that we were talking about, and is located in a valley. So it had a number of thermal inversions, and in 1948 this experienced a thermal inversion that trapped pollutants from steel mills a zinc smelter, sulfuric acid plant and several other industrial plants for 5 days, allowing the pollution to build up. It was capped over that valley. And 6,000 of the 14,000 inhabitants fell ill and 20 of them died. So basically, what I've talked about in this lesson, we've talked about the photochemical smog and industrial smog. What I will do in the next lesson is talk about the more regional air pollutants. These ones were more urban based pollutants. So the next one is going to look at acid deposition.